Here's question 6. Packy throws a 0.75 kilogram ball straight up out of the window as shown in the drawing to the right. Determine H2. So let's take a look. What I know is I know how high Packy is off the ground and what the speed of the ball is at point 1. Why is this not working? So I'm going to compare the total energy at point 1 to the total energy at point 2. Here's also what I'm going to do. I don't want to deal with GPE. So I'm going to set this reference height as H equals 0 right here. What I do need to do at the end is add 5 to whatever I solve for H2 because I know H1 is 5. But I just don't want to deal with that GPE, so I'm not going to. You could if you wanted to, but that would be extra work. So I'm going to label the types of energy at each point. So right now I'm comparing the kinetic energy at point 1 to the GPE at point 2. And I know that it's just GPE because it says V2 equals 0. So here we go. GPE at point 1. KE at point 1 is going to be 1/2 mv squared. We know that mass equals 0.75. And I know that V1 is 8 squared. Okay, so I know, let me just do a little math, 0.75 times 64. All right, half of 64 is 32, and then I'm taking 3/4 of 32, which is 24. All right, so the kinetic energy here is 24 joules. Last, I'm going to set 24 equal to GPE2. That means 24 is equal to mgh2. And remember, once I get h2, I'm going to add 5 meters because of the reference height issue. So 24 is equal to 0.75 times 10 times h2. Let me do a little math. All right, I'm going to get that h2 equals 3.2. But again, remember, now I need to add 5. I'm kind of running out of room here, but that's okay. So plus 5 because of the reference height, h2 is actually, you guys, I ran out of room. It's actually 8.2. And hopefully you followed that. 8.2 meters. And that makes sense because we know that our original height was 5, and it makes sense that it would go up another, 3.2 meters sounds reasonable.